Kia ora, Year 12. This is a differential equations question following on from today's surprise test and the request for more DE questions. So this is one of the ones in the Dr. Frost worksheet that I've just sent you, and I think it's a really nice question that pulls in lots of stuff that we've done. So you're asked simply to solve this differential equation, and you're given a point on the curve of the solution. So obviously the only thing we really know how to do with DEs is to separate the variables, so we need to take this and do that step first. So let's rewrite it as follows. E to the 2y times dy by dx equals negative tan x. Now we'll just get the y stuff together and get the x stuff together. There we go, and we're going to integrate both sides. So the left-hand side is pretty straightforward. It's a half e to the 2y, and I'm going to leave my plus c over this side, right? So here I've got the integral of negative tan x. So that's not immediately obvious. If you think about it, we know that tan differentiates to give me sec squared of x, but there's nothing that jumps out at me for the integral of tan until I write it out as sine x over cos x. We've done that in class a few times. Now hopefully you should spot quickly that we've got a natural log as my integral. So this is going to be the natural log. Let's try the natural log of cos of x and check what we get when we differentiate cosine of x. Well, we get negative sine of x, which is exactly what I've got up here in my numerator. So that's pretty nice. And then I have to remember my plus c. So if you were away when we did DEs, remember that we could start out by having a plus c1 here and then a plus c2 here, and then we'd combine them. But we usually just skip that step, right? So some of you might have done it like this, but it's fine just to go straight to this. A half of e to the 2y is equal to the natural log of the absolute value of cos c plus c. Okay, so that's what we've got to work with. Now the next thing we're told is we have to end up with a solution of y equals, but this is a good point to substitute in my particular solution, which is 0, 0. That's going to let me figure out what the constant is. So we have a half times e to the power of 0 is equal to the natural log of cos of 0 plus c. E to the 0 is 1, so we've got a half is equal to the log of cos of 0 is 1, so the log of 1 plus c. A half is equal to 0 plus c, so c is a half. So that gives us a half e to the 2y is equal to the natural log cos x plus a half. Now we're just about there, but we're asked to rewrite that in the form y equals blah, blah, blah. So let's just quickly work that through. We get e to the power of 2y is equal to what? What have I done here? I've done something weird. I need to just times through by 2. So we have 2 times the natural log of cos x plus 1. Now I'm going to take logs again. So the natural log of e to the 2y is just 2y. So 2y is equal to the natural log of 2 times that plus 1. Last step is to divide everything through by 2. So y is a half log of 2 ln of cos x plus 1. Now I could clean that up a tiny bit, but I don't need to. So that's a total perfect score. So let's just do that though, just for some fun. So y is equal to a half times the natural log of this thing here is the natural log of cos x. And now I can lose my brackets because I'm squaring it, plus 1. Okay, there really wasn't much point to doing that, but I'll just do one more bit because I can. So this is equal to the natural log of the square root of all that. There we go. That was completely unnecessary. Forget that I did that and just go on and try some of the Dr. Frost questions. Some of them are a bit harder than that, but they all use the big idea of separating the variables and then solving with more information. Thanks for watching.